This time, in this video, we're looking at testing a normal distribution. So if a variable is normally distributed, you can perform a hypothesis test to identify whether the mean of a sample is sufficiently different from the hypothesized mean. So here we have a question to show this, and we'll go through everything that we need to know, like a test statistic, as we go through the video. And this one says that the weight of beans in a tin produced by company A is normally distributed with a mean of 415 grams and a standard deviation of 3.4 grams. So find the probability that a randomly selected tin of beans has a weight of less than 409 grams. So this is just a simple question involving the normal distribution, and we're going to use our normal CD to say that our lower bound this time is going to be minus 1000. That's because it's saying it's going to be less than 409, so our maximum, which is our upper bound, is going to be 409. Now remember, this lower bound could technically be anything, just a low number. I normally use a minus 1000 just to be 100% sure that it would work, but you can really use anything which is within 5 standard deviations of the upper bound there. So the standard deviation is then going to be 3.4, and then the mean is going to be 415. Therefore, to press enter on your calculator, and we're going to get probability is equal to 0.0388. Next question we're looking at, it says that company A suspects that the mean weight of tins from a machine is lower than it should be. So here we have to write down a null and alternative hypothesis. So the null hypothesis is the assertion that the population the sample is taken from has a particular mean. And this is going to say that H0 is the mean is equal to the hypothesized mean. So that means in this case, what we're saying is H0, and we're saying that the mean is equal to 415. That is the mean it said, that's its hypothesis mean, and H0 is saying that that is true. In H1, we're going to say that this is actually not true. And it says here that it suspects that the mean weight is lower than it should be. Now, because it's lower, we're going to actually say that the mean is therefore less than 415. That is our alternative hypothesis. Then finally, if we look onto C, it says a sample of 20 tins is taken and the mean weight is found to be 413 grams. So carrying out the test at the 1% significance level to see if there is evidence that the machine is producing tins with a mean of less than 415 grams. So for this, what we're going to have to do is we're going to have to work out both the test statistic and the critical value. And if the test statistic is smaller in size than the critical value, then we're going to accept the null hypothesis. So in order to get the test statistic, first of all, the formula that it follows is going to be the mean, and that's the actual mean. So in this case, that's going to be 413. Then it's going to be minus the hypothesis mean, which in this case is going to be 415, that's its hypothesized mean, divided, so that there is taken, and that is divided, therefore, by standard deviation divided by root of the number. So this number here would be 20. So therefore that is equal to minus 2, because we've got that 413 minus 415 divided, and then that will be 3.4. That's the standard deviation over root 20. And that is equal to minus 2.603. Then if we're working out the critical value now, this is got by using the inverse normal. And it also uses the significance level. So we're going to say that the critical value, the area of this, now this is where we look at the significance level. Now the area is going to be equal to the 1%, means 0.01. Then we're going to standardize everything else. So we have 1 as the standard deviation, and then mean as 0. Therefore, that is equal to minus 2.3263. So therefore, what we're going to conclude, if just at the bottom here, is that because the test statistic is larger in size than the critical value, so therefore what we're going to say is reject the null hypothesis, which means that the mean has changed. So that is what we're saying, is that the mean is actually now less than 415 grams. So in part B we have a very similar question, but this time it says that the length of a bus journey from Leeds to London is normally distributed with a mean of 220 minutes and a standard deviation of 8 minutes. So first of all we need to find the probability of a bus taking longer than 235 minutes. So in order to do this, we're going to be using the normal CD. We get our lower bound, our upper bound, then we've got our standard deviation and our mean. Now in this case, our lower bound is going to be 235 because it's saying about taking longer. So we've got the probability that X is more than 235. So that means that that's going to be our lower bound, which means that we can put this as, we'll see, 1,000. Then our standard deviation is 8. And then our mean is 220. Therefore, probability is equal in this case to 0.0304. Then if we go on to B, it says the bus company suspect that the mean bus time has changed, so write down a null and alternative hypothesis for a two-tailed test. So this time we have a two-tailed test, which just means that our alternative hypothesis can be slightly different. Again, in this one, we're going to say that mean, now they expect it's going to be 220, as it says there, a mean of 220. Our alternative hypothesis say that mean is going to be not equal to 220. It's a two-tailed test, it's just not equal to 220. Then what we have to do again is we have to work out the test statistic and the critical value and compare them. So in order to work out the test statistic, first of all, test statistic there, we're going to say that we've got 230. Now that is our mean minus our hypothesized mean, 220. That is divided, therefore, by the standard deviation, which is 8, over the root of the number of bus journeys, which in this case it says is 10, and then you've got our mean time there of 230. That is therefore equal, our test statistic is equal to 3.953. Then if we look at our critical value, CV, we're going to be using that inverse normal again. Now this time it's again at the 1% significance level, but it's a two-tailed test. Now we also need to draw a bell-shaped curve here to show what is going on. So we have in this thing at the 1% we've got going to be 0.005 now. So 0.005, that's a very small area there of 0.005. But we have to do less than in this case, which is going to be all this area here, all this, which is going to be 1 minus 0.005, which is equal to 0.995 instead. It just will change it from a negative answer to a positive answer. It doesn't necessarily matter that much, as it will still give us the same outcome. But in this case, we're going to be saying that our area, remember this is using inverse normal, our area is equal to 0.995. Then we're going to standardize everything else. We have 1 and 0. Therefore, put that in, what we're going to get is that is equal to 2.576. So therefore, what we're having to conclude at the end is similar to the first thing. We're going to be saying the test statistic is greater than the is greater than the critical value. So that means that we're going to reject null hypothesis, and we're going to say the mean has changed from 220. We don't know if it's gone up or down, it's just changed, and that's why we've got that two-tailed test there. So the next question is using the p-value. And the p-value is essentially another thing which is used from the test statistic, and when it is greater than the significance level, you accept the null hypothesis. So the p-value is gained by using the standardized normal in normal CD and putting the test statistic as either the lower or the upper bound. Now it's the lower bound when the test statistic is positive, but it's the upper bound when the test statistic is negative. So we'll see how that works when we're looking into this question. Now, it's a long question which says that the heights of adult men in a large country are well modelled by a normal distribution with mean 177 centimetres and variance 529 centimetres squared. And it's thought that men who live in a poor town may be shorter than those in the general population. So the hypotheses we have, H0 is that the mean is equal to 177, and in the one-tailed test we have the alternative hypothesis, the mean is less than 177. So these are tested at a 10% significance level with the assumption that the variance of height is the same in the town as in the general population. Now a sample of 25 men is taken from the town and their heights are found to have a mean value of 171 centimetres. So first of all, let's calculate this test statistic. So we'll have its mean this time, which is 171 as it says here, that's its mean, minus its hypothesized mean, which is 177, and that is going to be divided by the standard deviation. Now the standard deviation in this is going to be, well, we have the variance here, so it's going to be root 529, so divided by root 529, and then that is going to be over, that is going to be divided therefore by the root of the number, which is the root of 5. So the root of 25, which is 5. Now that is, therefore, put that in the calculators, and what we are going to get is minus 1.3043. Now it's time to calculate the p-value of the statistic. And as I said, what we're going to do is put this in the normal CD. And if it's going to be a negative, that means that we're going to be putting it into our upper bound. So that means that we can say our lower bound is going to be minus 1,000, say. Now as it's negative, we're going to say our upper bound is therefore equal to minus 1.30443. Then we've got our standard deviation, which we're going to standardize. So we're going to say that's 1, and then mean is equal to 0. Therefore, our p-value is going to be equal to 0.09607. So then in C, what we're going to have at the end here is we're going to have to state with a reason whether the null hypothesis is accepted or rejected. And in this case, as the p-value and is less than the significance level. Now this is because the significance level is 10%, that's going to be 0.1, this is 0.096, it's very close, but it is still less. It means that you would reject the null hypothesis. Therefore, the mean has changed from 177. And in fact, what it has is it's now less than 177. So the final question we have here is all about bananas. It says that a banana farm finds that the banana masses are well modeled by a normal distribution with mean 125 grams and variance 150 grams. So during one summer, the bananas are thought to be larger than usual. So let's state the null and alternative hypothesis. So therefore, what we're going to have is we're going to have H0, and that is going to be that mean is equal to 125. That's because our mean there is 125. That means that H1, our alternative hypothesis, mean is therefore going to be more than 125. That's as our alternative hypotheses. And then in B, it says that a sample of 42 bananas is selected and their mean mass is 131 grams. So let's first calculate the test statistic and then the p-value. So in order to do the test statistic, as we've done multiple times before, we're going to have this 131, which is its mean there, minus its hypothesized mean, so that's 125, so that'll be 6, divided, and then we have our standard deviation. That's the variance, so it's going to be root 150 divided therefore by root of n, so that's going to be over root 42. Now that is therefore equal to 3.1749. So now we have that, we can use that to calculate our p-value, and as this is a positive value, this shall be our lower bound. So we're going to say our lower bound is going to be equal to 3.1749. Our upper bound is therefore equal, we'll say to 1,000. Again, anything high will do. Standard deviation, that is equal to 1, and then our mean is going to be equal to 0 because we're standardizing it. So therefore our p-value is going to be equal to 0.007494. Which you also say is 0.001 if we wanted to. So therefore, now we have our p-value. So state with reason whether the null hypothesis is accepted or rejected at the 1% significance level. So we will compare this p-value to the significance level, and we're going to say that 0.01 in fact, is greater than 0.001. So the significance level is greater than the p-value, so therefore, reject H0, and that's using that knowledge that we had before. Then if we go on to D, it will be asking us to determine the conclusion of the hypothesis test. So this is a bit more of a wordy question. So what it's going to be asking therefore is we're going to say that the mean mass of the bananas have changed and are now greater than 125 grams. Then finally in E, it says discuss whether it is reasonable to say that the mean mass of that summer's banana is 131 grams, and that's what we got in those 42 bananas. Now for this, it's not actually reasonable to say this, and you say that no, it isn't, and that's because we have only found that the mean is greater than 125 grams. That's all we've shown. We haven't shown anything else, and even though 131 grams may be a good estimate, we haven't shown that from the calculations that we've done. So thank you for watching this video, and see you soon. Bye.